Pythagorean Theorem, Level 2. Find the length of the third side, if necessary, write in simplest radical form. So step number one, my directions I want you to do for appropriate work to draw the triangle and label the side lengths. So I'm going to draw this to the best of my ability. I'm also going to keep that these sides be horizontal and vertical so I can clearly see which one is my hypotenuse and which is my legs. So obviously there's the right angle, so that means that this, number 5, is a leg. This side over here, this ends up being my C or my hypotenuse, so that's 9. And then this one over here is an unknown. So using red, this is obviously C. I'm going to call this one A, and this unknown, I'm going to mark it as B. I can also use my cheat guide from the other day, the legs, which is 5 and A or B. These are the sides that actually create the right angle. They actually touch that square. Whereas the side that does not touch, the side that's across from the right angle, that's my C or my 9. And also remember the hypotenuse is always the longest side. So whatever B is, as long as it's less than 9, it should work out. Okay, so let's plug the values. Step number 2 is we want to put the numbers in the given variable into the Pythagorean theorem. So I have A squared plus B squared is equal to C squared. I'm going to put in 5 for A. My B value is going to remain B. And my C value is 9. So 5 squared is 25. B squared will stay B squared. And 9 squared is 81. Then to isolate the B squared, I'll subtract 25 on both sides. And now I have B squared is equal to 81 minus 25 is 56. Then I'll get rid of the square, or that little 2, by square rooting, because that's the inverse operation. And then the little 2 exponent and the square get rid of each other, and we have B is equal to, and now we just have to go through the process of breaking down 56. So let's do this. So step number 1, we're going to break down 56. I typically try and break numbers down by dividing by 2s and 3s because those are pretty small prime numbers. This is even, so it's going to be 2 and 28. 28 will be 2 and 14. And don't forget to circle your primes. That lets you know you can't break that down. And then 14 will be 2 and 7. After that, I'm going to take all the prime numbers and put it underneath the radical, and I'll switch over to red just to kind of differentiate that. So I would have 2 times 2 times 2 times 7. I'm going to pair up anything, so that pair of 2's will disappear, and I'll write 1, 2 on the outside. And it looks like I get to my final answer. I've got a 2 on the outside, and then on the inside, the 2 and the 7 stay there, but we're just going to multiply them back together. So right here, this 2 root 14 is what I'm going to put in place of root 56. So my final answer for this one is my B value is going to be 2 root 14. And that's what we'll box as our final answer. So that kind of gives you a quick review of how to use the Pythagorean theorem and how to simplify a radical. I'm going to give you another example. That's where we're solving for a leg, so let me go ahead and find one as finding for a hypotenuse. Okay, I found one here. Find the length of the third side, if necessary, write in simplest radical form. So again, number 1, let's draw the triangle. And notice this one's kind of on an angle. I'm going to draw a horizontal and vertical for my legs. Put in the right angle. And this means this is 9 and that is 6. I'm going to call this one A, and I will call this one B. This one over here is my unknown. This is my C. And again, remember that this is C because it is across from the right angle. All right. Let's color code it just like we did the other ones. So my legs actually touch this square, the right angle, and that's 9 and B, and this is 6 and A, or you can switch A and B around. The side that does not touch the side that's across from the right angle, that's my C or my hypotenuse, and this is the longest side. So before I even try to solve this, I do want to let you know that the expectation is 9 is the biggest leg, so as long as this is bigger than 9, it's fairly reasonable. So we'll start with the theorem. A squared plus b squared is equal to c squared. 6 and 9 will go in, so I've got 6 squared plus 9 squared is equal to c squared. So that's going to give us 36, and this is 81 is equal to c squared. 36 and 81 is 117 is equal to c squared. And then to get rid of the square, we'll square root both sides of the equation. Remember, properties of equality. Whatever you do to one side, do to the other. On this side, c squared will simplify just to c because the square root and the square will get rid of each other. Now what we have to do is we have to break down 117. Now, 117 is odd, so I can't divide it by my favorite number, which is 2. But this actually does divide by 3. And I know that it divides by 3 because the rule for 3s states this. If you take a number, and it doesn't matter how many digits, and you just add the digits together. So watch this. 1 plus 1 plus 7. That's 2 plus 7 is 9. Ask yourself, once you've simplified this number by adding them, if 3 goes into 9, and most everyone knows, like, majority of people were like, yeah, 3 goes into 9. Okay, so I know 3 goes into 117. It doesn't tell me exactly how many times. It just lets me know that it works. But I happen to know that 3 goes into 117 39 times. 39 is not prime. Again, I'd like to divide it by 2's, but that's odd. So then I'm going to test it again. I want to see if 3 will go into 39, so I'm going to add the digits. So let's see, 3 plus 9 is 12. I know that 3 goes into 12, therefore 3 will also go into 39, and it's actually 3 multiplied by 13. And technically you could test it again. Watch what happens. Add 1 plus 2. 1 plus 2 is 3. 3 goes into 3, therefore 3 goes into 12, and etc. So there we go. So we factored as 3 times 3 times 13. So the second part of our step, we're going to put 3 times 3 times 13. I'm going to pull out this pair of 3's and put one of them on the outside. And so it looks like my final answer is going to be 3 root 13. And so that's what I'm going to get rid of. I'm going to get rid of the square root of 117, or root 117. And in its place, I will put 3 root 13. And the only difference is that one's been simplified. But we had to do that because that's what the instructions said. Simplest radical form. And there you have it. So hopefully that's a good review of how to, in this example, solve for the hypotenuse and checking the divisibility rule for 3's. And then the first one was solving for a leg and then, again, simplifying.